Hello everyone and welcome to the Cisco Community live event. Today we're going to talk about basic Wireshark for networking students. My name is Hilda Artiaga and I am a community manager of the Cisco Community and the host of today's event. Well, before we start, I would like to tell you something about the Cisco Community. Well, the community is an online forum with over 500,000 members where you can get answers to your technical questions prior to opening cases with the Cisco tag. Also, you can answer questions from other people or contribute with documents, videos, and blog. And you can also rate all the content that is available in the community. So before we start, I would like to share with you a couple of events and activities that we are currently having on the community. So first of all, we have this Ask Me Anything following the event. This is a forum event where you can place all of your questions related to the topic that we are presenting today. That is, for example, if you have a question and we did not have the time or the opportunity to answer it during the live event, we will post this question at the forum event and the expert Moises will be helping us out to answer to it. Or let's say that maybe 1 hour after the event or maybe a couple of days after, you were thinking about everything here and you say, well, I have a question. Then you just come back to this forum session. Even though the live event has already passed, you just post your question there and Dr. Moises will be helping out to answer your question. This forum event is going to be open till Friday, April the 24th. Okay? So all of the links and all the information that I'm mentioning will be available on the chat panel, which is allocated at the right side of your menu. Or if you're on a mobile device, it's just on the 3 dots of the menu that is right there. Also, we would like to invite you to a special Cisco Community event. It's a forum event as well. We know many people are struggling right now that working from home and due to COVID-19, so we have arranged special sessions about collaboration and security. So you can ask all of your questions in this case about the configuration, troubleshooting, and best practices on any Connect, VPN, and ASA and FTD. This event is going to be open in April this Friday, April 17th. So you can place all of your questions. Something important that I would like to call here is if you speak a different language rather than English, this event is available in all the local languages that the community has. That is, it's available in Chinese, Japanese, Russian, Spanish, Portuguese, French. So if you have questions, you just please go and post it there, and people will be helping you out so you can maintain your network secure and your workers as well secure. Also, we'd like to invite you to become an event top contributor and to participate in the community. We recognize people who are always helping out others and who are helping us to rate content as well. So how we do that and how we can be recognized and earn an award in the community, that's very easy. First of all, help us out to rate the content, right? It's not only a way to say thank you to someone who has been helping you out. It also helps us out to recognize and identify the content that has high quality in the community. The way to do it is very easy. Let's say someone gives you just an example or give you an answer to a question that you provided, and you find the information is useful, then you can give it a helpful vote. To do it is very easy. You just click on the start, and you will give a helpful vote. Or let's say that they give you the solution. You can mark it as an accepted solution, and that will help out people in future that have the same question or a similar question to identify what is the solution for that. And as I mentioned before, we recognize all people there. And well, just to get started, I would like to introduce you to our expert today. He's Dr. Moises Andre Nisenbaum. He's a full-time professor at the Federal Institute of Rio de Janeiro since 1986. He has experience in the information science area, and he specializes in information and communication metrics. In the area of education, he works with different information and communication technologies with a focus on networks, help desk, 5-6 teaching, and youth, and adult education. Moises holds a bachelor's degree in physics of the State University of Rio de Janeiro and a master's degree in physical science from the Brazilian Center of Physical Research. He holds a PhD in information science from the IBICT. Welcome, Dr. Moises. Thank you so much for being with us today.
Thank you, Hilda.
And we also have the question managers, that is people who are going to be helping us out to solve all your questions. In the meantime, you're receiving this presentation, I will start with Liz. Liz Ellis is a full-time technical consulting engineer on the enterprise routing and switching team at Cisco's Technical Assistance Center, that is the TAC. He provides top-level technical support for global customers with Catalyst 9000 and 6000 switches. Previously, he was in the service provider TAC team. Before joining Cisco, he worked for 4 years in Ericsson, solving customer challenges and making suggestions for massive network optimization. He holds a bachelor's degree in communication and electronics engineering from the Instituto Politécnico Nacional in Mexico. Welcome, Luis, and thank you so much for being with us today. And we also have Antonio Santiago. We call him Tony. Tony is a team leader of the enterprise switching, routing and switching team at Cisco's TAC in Mexico. He specializes in the troubleshooting of many Cisco switching platforms, such as the Catalyst 6000, 4000, 3000, 9000, and industrial Ethernet solutions as well. Tony joined Cisco in 2014 as a customer support engineer with the LAN and switching team, and he holds a bachelor's degree in computer systems from the Instituto Tecnológico Superior de Zapopan in Mexico as well. So, Tony, thank you so much for being with us today, and welcome to this session. And well, for all of you who would like to have a deeper look and check out more into detail what Moises is going to present today, you can check out the presentation. It's available in the community, and you can also take it from you. That is downloaded. So the link is going to be in the chat once again, if you want to have a look. And this is a friendly reminder. You can submit your questions at any time. We will be here to help you out. We just would like to ask you to please use the Q&A panel to submit your questions. That helps us out to identify the questions easier and answer them easier. And please use the chat panel for all other inquiries like my screen freeze, I have no audio, and any other logistic issues. So once again, thank you very much for being with us today. We hope you learn a lot. And well, Moises, it's now time to learn a lot from you.
Thank you very much, Hilda. And thank you very much for the invitation. I'm very glad to be here with you, Jimena, Gabriela, Tony, and Luis. Today we're talking about basic Wireshark for networking students and also to teachers, okay? Because I believe that it's not possible to understand networking without Wireshark. Wireshark it shows us the networking happening, what's happening there. So it's so important to know this tool. And today's presentation, I will present you the basics of this tool. Okay. Here the agenda. Here, firstly, we are talking about what is Wireshark and some of its uses. Okay, how can be used and what is this? Secondly, we are showing Wireshark in practice, some with TCP. TCP, of course, is a well-known protocol for everybody that's studying networking. So and it's rich to see this working in Wireshark. And most of the analysis of the security analysis and also other protocols learning, we use a lot to analyze TCP messages. Okay, and in third place we have the span and airspan, two Cisco, can I say, protocols or way of seeing things, of capturing remotely the traffic. Okay, and then finally we will observe 2 or 3 other protocols. So in practice, 2 using GNS3. Okay, so I hope you enjoy. First of all, I will ask you, this question will appear for you. I will ask you, what is your experience in Wireshark? I want to know, because I would like to know if you know an expert in Wireshark or not, because we can see, I hope many of you know basics of Wireshark, but let's see what will be the answer. Okay. So let's wait some minutes well, you see that you are here. There are many people here because I believe you know the how important is Wireshark for networking, learning, and teaching. And there's something funny that happens with teaching with Wireshark is that students can test, can experiment, can explore. So you have to know the minimum of Wireshark to explore this tool. Okay. So we have the answers. Okay. 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 Right. Very good. Okay. Well. What is Wireshark and how it is used? A little bit of history. It started in 1997. At that time, internet was in the beginning, and commercial internet. It was in the beginning, and this guy Gerald Combes started with this tool, this graphic tool, to analyze traffic. Okay, and it was called Ether-Real because it was capturing traffic from Ethernet. So it was a revolution because at that time there was some captured traffic, but it was all in the screen in CLI, so it was difficult to understand. In 2008, it changed its name to Wireshark, and Wireshark 1.0 was launched. It was very good, and in 2015, many improvements with the interface and with the framework too was implemented. Nowadays we are in version 3 with the same framework. Okay, so this is this. Millions of people use the Wireshark for studying, also for work. Okay. Some of the things that the Wireshark can do for us. First of all, Wireshark is a network protocol analyzer. Okay, it can capture and analyze networking traffic. Okay, and why it is good? First of all, because it is free. Okay, because of this, it is good, but because there are many other tools that are paid that do much more things that Wireshark does. But it does many things. For example, it supports hundreds of protocols, not only TCP and IPv4, IPv6, many of other protocols. You can capture offline and online. In other words, you can capture traffic, live traffic that is happening now, that is connected to your network card, for example, or you can save the capture and send to somebody this capture and analyze after that. Okay, so you can also read offline files. It is multi-platform. It runs in Linux, Windows, Macintosh, and other. It can read data from many different sources, interfaces, like Ethernet, of course, USB, Bluetooth, wireless. So it can capture in a layer 2 of the model from many cards, different cards. Okay. And also, it can import and export to other softwares that does the same thing. Okay? So if you have the opportunity, we will see this happening. Okay. Right. Here's the screen. This is the Wireshark screen. It's very simple. Okay? 3 panes. First of all, we have the packet list pane. This is a summary of the packet that is being captured or that is in a file saved that you open. When you click on one of these lines, it will open this packet details pane of each one of this one. You can see details here, and the packet bytes pane is the bytes that represent each of its lines here. Okay, so you have these numbers in hexadecimal and also in ASCII, the ASCII translation of these ASCII2 translations of these bytes here. Okay, so this is very interesting. Okay, packet list, packet details, and packet bytes. Good. How Wireshark captures traffic? How is the framework? How it works inside? Okay. First of all, it can capture from networks live or from a file in a drive, for example. Okay. If it enters from the network, it passes first for a driver here that works in data link layer. Okay. It can be libcap, win pickup, or M pickup, USB pickup, etc. Okay, so this is the software that connects the network card to the dump cap, that is the capture engine. Okay, the capture engine is the same for any layer 2, layer 1 interface. Okay, so here in this place there is a capture filter. Okay, for example, if you want to capture traffic 24 hours, 48 hours, okay, so you don't want to analyze everything that is happening in the network. So you can put a filter here. So the file you are saving will not be so big. Okay, so you can put a filter here. For us that are studying networking, most of all, will work only with these display filters here, okay? Because firstly, because it's easier, and then secondly, because the file, I believe, in a classroom won't be a big file for us to use this capture filter. But you can try this filter too, okay? So the gold mine, okay? Chappell is an expert. She's an expert in Wireshark. In his book, he called this core engine here a Wireshark gold mine. Why? Because here are all the intelligence of Wireshark. Okay, it capture the traffic, show the traffic, okay, and then analyze the traffic, and you have this analysis on the screen. It's very, very good. It's very interesting. Okay. Okay. Here's the when the file comes from the drive, the default file format when you're saving the capture is pickup ng, but it can read pickup too. It's the older version. Okay. And that's it. This is framework cute. Okay. Let's go. Basically, this pane here that shows the details of the packet, it is a mirror of the TCP/IP model layers model. Okay, so you have the network access layer here. You have the protocol that runs on the layer, this layer here, Ethernet 2, for example. You have here the internet level, the internet layer, and here you have the internet protocol, for example, version 4, transport layer, TCP, application layer, for example, HTTP. Okay, so there is a one-to-one relationship between this TCP/IP model and the details pane. Okay, this frame line here is metadata created by Wireshark here. Okay, so this is not a capture thing. This is calculated by Wireshark. Okay, so that is. Okay, I want to show you now a site that has many, many, many captures that we can try. It's very interesting. Let me show you here. Okay, so this is Pocket Life. It's very interesting because you can learn from captures that has been already saved. Okay, so I will open one of these to show Wireshark live here. For example, let's try some routing protocols. So I want to learn, for example, BGP, this here. So I will download this file. I will put this file, for example, in my desktop. Okay. So I will open it, and Wireshark will automatically open this. Oh, this is a small file. Okay, no problem. Here we have the file. Somebody have captured this, saved, and put online for us to study here. Okay. So, and also you can see the same thing in CloudShark. That is a kind of online version of Wireshark 2. So this is amazing for us to choose captures, selected, filtered for us to see everything that is happening in the communication of this protocol here. So this is a very interesting site for you to study. Okay, let's talk about filters. Filters. There are two filters: capture filter and display filter. There is a syntax here. Here's who knows who worked in Linux with TCP dump in Linux can recognize this syntax here that we use in capture filter. Most of the time we would write here like something simple here like TCP or TCP port or another one word filter. But if you want to know more, here are the syntax of this. By the way, this is in Pocket Life too. Okay, so here's the sheet. So, and now here, when we enter in the capturing leave or open a file, we can access the display filter that will filter what is shown in the screen. Okay, and this is a sheet of keywords that you can use in this filter. Okay, so let's demonstrate this. Let's see. Let's capture some traffic. Okay. Okay. So here in the first screen, when you open the Wireshark, you'll see a list of interfaces that are installed in my computer. Okay. So I will choose this Ethernet. That is my card that is connected to my network and internet. Many things are happening here now. Okay, all the time. Especially the WebEx is here, of course. And we can see the filters. For example, let me go to some site here. Okay. For example, I'm going to cisco.com. I'm going to cnn.com. Okay. So let's see if it was registered here with a filter. Okay. So let's see if my computer asked some DNS server for something. There was, and there is happening many DNS consoles here. If you can, and that'll work if you want to say I work with IPv6 DNS server here, okay, and here are the layers of TCP model. You see DNS here are using DNS queries here are using and replies to UDP protocol, port for 53, and details of the query. What was the query here? I asked someday about this gemcriterial.com. And what was the answer? Maybe the answer is here. I don't know. Okay, we can filter by this. Okay, so this is a kind of filter. If I want to filter HTTP, let me see if it was some HTTP traffic in my. Yes, there was. Okay, here HTTP to this site here. So we can put filters, display filters here. Okay, also TCP dot source port equal to 443. Let's see if I have a communication with HTTPS. Okay, there was. So the filters are there for you to find things in this many information you have in your capture. Okay, but you do not have to memorize things. Okay, if you, for example, see a TCP packet here. Okay, any of this. Here's the filter TCP. Okay, so I want to filter, for example, all the TCP communication that has the source port equals to 1594. So what we have to do? Right click, apply as a filter, select. So Wireshark will do the syntax for us. Okay, many of the things we will do with these icons here and the right click. Okay, so you can prepare any filter with the right click with any of the components here of the data inside the metadata, inside the headers of these PDUs. Okay, so you want to make a filter, you can. Another thing very interesting that that Wireshark does is, if you see in these details here, you will see many information between brackets. Okay, all this information between brackets is not captured. It's Wireshark calculus. So Wireshark put here in this segment here a stream index number 65. The TCP length is also calculated by analyzing the captured traffic. So this is calculated. This is not inside the header of the segment. Okay, it's very interesting. In particular, this stream here is very interesting because this is the conversation between these two ports here. So instead of putting a filter that has these two ports as source or the destination, I can filter by the stream index. Okay, so I can filter here by the stream index. So I will have all the conversation here. You see the SYNAC and the set in FINAC here. Okay, so there was many conversation. There is happening many conversation because I didn't stop. I will stop this capture here. There is many conversation here. Let's see what was the first one. The first one that I captured was this one here. Okay, the very first one conversation that I have captured is here, and then it goes to 2, 3, 4, and 7. Okay, so this stream index we will use a lot. Okay. Okay, let's take a look, for example, to this TLS communication here. As you know, TLS is encrypted, so it's not possible to understand anything here. You know, the bytes are all unreadable here. So let's try to find HTTP traffic that is not encrypted. Okay, let's see if we can read things here. Okay, see, keep alive, connecting, always unencrypted. Okay, because this is an open, this is an encrypted protocol, HTTP. Okay, same happens to DNS or some other layer 7 protocols. So you can see this. if you want to see what's inside the, for example, TLS communication, you will have to enter an encrypt key inside Wireshark. It's possible. Okay. Okay. Let's go on. Let's minimize the screen. Okay, let's do the TCP analysis now. Let's remember. First of all, let us look closely to this detailed pane here. Okay, what do you have here? All of these lines here are the fields in the header of the TCP in this case, but on any protocol. So what Wireshark shows here in this middle pane is nothing but the fields in the header of in this case, the segment. Okay, so you have the sequencing number here. You have the sequencing number here. Acknowledgement number here. You have acknowledgement number here, and go on. These flags here are these control bits here, and etc. Okay, so this is the meaning. When you study this ugly thing here, you can see in Wireshark this beautiful thing. It's like a revelation, you know. And well, the first time I saw Wireshark, I had, oh, revelation! I see everything, and now I understand. Thank God. Okay. So that's it. So the three-way handshake, everybody knows this. The three-way handshake happens in the beginning of TCP communication. I'm not here to explain TCP, okay? I'm here to show you how to see this in Wireshark, but it's very interesting, okay? So you have the SYN, CIVET, SYN-ACK, and then the ACK, the three-way handshake in the beginning of the TCP communication. So we will see this in Wireshark, okay? Of course, Wireshark is very well behaved. So when it finishes the communication, also there is a section finalization sending FIN, FIN-ACK, and FIN, FIN-ACK. Okay, so we will see also this finishing of communication, of TCP communication. Okay. Also, we'll see this in Wireshark in a moment. But firstly, I'll remember how the sequence numbers and acknowledgement numbers works. Okay. So what is a great responsibility of TCP? Okay, dividing the data that came from application layer. So from application layer can come a big data. So TCP fragment, divide, segment this big data in smaller segments. And these segments, they can have different sizes. For example, here 1,000 bytes, 1,400 bytes, 900 bytes, 200 bytes, 500 bytes, for example. Okay. So when it sends this first segment here, this segment would have a number. The number, for example, if it is the first segment, it will have the number 1, for example. Okay. Then the next segment will have the number 1001 because it's 1 plus 1,000 bytes. The next 1001 plus 1,400, it will be 2401. Okay, so we have these numbers here. Okay, and the client will receive this. Okay, and from time to time, the client will answer the server with an ACK segment. This ACK segment will have no data. It's empty, but it has the flag ACK turned on, and also the acknowledgement number, the number of the segment that the client is expecting to receive next. Okay, so it received 3501 plus 500, and plus 1 will be the next segment. Okay, so this information we will see now in Wireshark. Okay, so let's see. Let's open the Wireshark here. So for that experiment, I will start again the capture. Okay, let me turn off this filter here, and I will go to a site that I saved here to download in FTP a 20 megabytes file. Okay, so I am downloading here. Okay, save, replace, because okay, everything is done here. The file is already here completed. Okay, so I will close this tab. Okay, let's see. Everything is done here. Let's try to see FTP here. So, okay, that is traffic FTP here. But you know that FTP is not alone. FTP data also come together. This is the file I am downloading. The FTP is just the control. Okay? So let's see, let's stop the capturing, okay? And let's try to see firstly the FTP data, okay? And then the TCP communication that happens here. So I will go here in TCP protocol, and this stream index I will filter by this stream, okay? So I have all TCP communications of the control of FTP, okay? So, okay. SYN-ACK, triple handshake. Good, very good. Also. SYN-ACK. Okay, the server has set my communication to, okay, no problem, but there is a finalization here. So you will see the SYN-ACK, and SYN-ACK. Okay? Good. Also, we have here these columns here that are very useful. Okay? What is this? The length of the segment. Okay? This sequence number here. The acknowledgement number, TCP length. Let me put this in also in as a column. So I have the sequence number, the TCP segment length, and the next sequence number expected. This next sequence number is calculated by Wireshark. Okay, so that's it. So that is, for example, here. Here is the number, section number here is 21. The segment length is 0. So the next they he's expecting is 21. 21 is here. Okay? Plus 34, we have 55. 55 is here. Okay? Remember that TCP is a bidirectional communication. Okay? So this is the communication from and then you have here, for example, 55 plus 23, 78. 78 will be here. 78 plus 0, 78, 78. So we are going like this. Okay. From time to time, the client will send the ACK. You know, take a look at this number here, 177. It's the same number that Wireshark had calculated. Okay. So, okay, the client received all the segments. That's right. Let's go ahead and send more data. Okay. If you take a look at the other stream, okay, the data stream, FTP data. Let me filter by this stream 19 here. Oh, not this one. Maybe this one. Stream 32. Okay. Here again, we have another communication, fin, finac. Let me see if it's finished. Yes, fin, finac. Okay. And also, you see this ugly black segments here. What is that? When Wireshark puts something in black, it means that something that was not expected it's happening. For example, segment not captured. So it's easier for you to see. If you don't like colors, you can turn off colors. Okay, I like colors, no problem. So let's take a look to this three-way handshake here and information that they exchange here. For example, when they start the communication, the TCP session, they agree with some parameters. For example, maximum segment size. Okay? So the client and the server will say to each other what will be the MSS of this communication. And you see that they obey this rule. The server is sending segments with this size for 1440. Okay? Okay. Other thing that is agreed is the multiplier of the window size. Okay? What is window size? Window size is, in a few words, is the size of the buffer of the server and of the client. The maximum data that I can support. So don't send me more than this because my buffer will overflow. Okay? So this is the window size. The window size value will be 64800, but in practice it will be multiplied by 256. Let's see in the middle of the communication. So window size for the server is 225, but the calculated Wireshark do this for us. It will be this one because the scaling factor in the case of the server is this. But in the client, the client is different. Okay, the client, the window will be bigger. Okay, because the client normally has more memory to do these communications. Okay, so and this happens in the very beginning of the communication, and you can see all these options, these very important options that happens here. Okay. Other thing also, the SAC. Okay, the SAC will allow TCP to resend segments, not all the segments that have sent, but part of the segment that was lost. They will be able to inform what segment that was lost in a lot of segments. For example, in this case here, for example, if the client lose this segment, it can inform the server that was this one that he lost. So the server sent only this one, not all again. Okay? But the traditional TCP without this modification, it will be all. Okay? Okay, this is TCP. Let's go on. Now a break to a question. Okay, I want to ask you if Wireshark is able to capture something that is distance. For example, I was capturing only the traffic that was directly connected to my network card. Okay, so for example, if there is a computer or a router or a switch in the second or third floor here, can I capture there? Remote capture? Is it possible? What do you think? This is the pulling question number 2. Let's see, what do you think? So the first answer is not possible. Of course, Wireshark is installed in my computer. Is it possible? Second answer, only offline files. Okay, I can see, but you save the file, send an email for me, and I open here. Oh no, I can do live capture remotely. What do you think? Okay, yes, the right answer is letter C. Okay, that's right. It's possible. Fortunately, it's possible. How can I do this? Tap hardware. A hardware you buy and you put in your network so you can send with this hardware, send it for you remotely. It's very interesting. Okay, so there are many types of tap hardware, from $100 to thousands of dollars. Okay, this is very interesting. The other way that was used in the past, but it's not using anymore because of security problems, it was a protocol called remote pickup. Okay, and that was sent the traffic to a TCP, normal TCP connection. So, for example, you install WinPickup in your Windows system. So you can enable this protocol to send your traffic to anywhere in the world through a TCP connection. Okay, but of course, it's very unsecure because the traffic is totally unencrypted. So because of this, we don't use this. Okay, there are some other commands or programs that you can run in Linux and also in Cisco IIS that sends traffic, but through SSH connection that is encrypted. That's okay. You can use it. Good. But I will show you this pane technology that is a Cisco technology and RSPAN. This is a way of capturing remote traffic from remote ports. Okay. Here is an example that I will show you in Packet Tracer in a moment. Okay. So here, SPAN and RSPAN runs in Cisco switches. Okay. So you have a Cisco switch here, and you can configure this port, for example, to be the source SPAN port. Okay. And any other port to be the destination port, in a way that this sniffer here will see a copy of the traffic that is happening on this port. Okay, so it's very interesting, and you can study almost anything you want with this technology. Okay, you are putting in practice. For example, you are configuring routers, OSPF, BGP, anything. So you put a switch there and capture the traffic and study what's happening. Okay. So here is a packet tracer that will demonstrate to you how to configure a SPAN. It's very simple and how it works. Okay. Let me pick up the packet tracer here. Okay. Here it is. So that's right. Here we have the DHCP server here, and the computers have already the IP addresses here. Okay. So here is sniffer. It's simulating a Wireshark here. Very simple Wireshark. Okay. So we have the package pane here, list packet pane list pane package here. Okay. So I'm not showing everything here. I will put a filter here, like Wireshark filter, ICMP, only pings. Okay, let me clear here. Many things that happens here. Okay, let's see if Wireshark can see the ping that PC1 sends to PC2. Okay, let me see what is the address here, 101. Okay, Let's go to the command prompt. Let's put the sniffer here and see. So, ping. I'm not seeing anything because the switch isolated traffic and it happens only on these two interfaces. This interface here is not happening anything. Okay. What I will configure here is a span that this interface will spy what's happening in this interface here. Let's see the names of the interfaces here. Okay. So what I will do? Fast 01 will be the source, fast 03 will be the destination. Okay, it's a very easy to configure. Enable config. Let's put a name on this because I don't like things without a name. Okay, so the command is monitor session, and I put we can have many sessions happening simultaneously. So I will put session number 1, for example. The source will be the interface fast01. Monitor session 1 again, the same session where the destination will be the interface fast03. In this moment, this interface here stops working in this network, and is here will happen a copy of what is happening in fast01. Let's see if it works. Okay, let's do the same test. Oh, now I see. Now I see a copy. Okay, I'm not cheating, okay? Because you see here that the destination is 101, not 103 here. Okay? It's 102, not 102, it's 101. So it's capturing, mirroring this port here. So span is very interesting, very simple to configure. Okay? Next. This is my lab. Thanks to eBay, I have a lab at home. Okay? I would like to show this in a real equipment, but we do not have time. Okay? This is our span. Okay? Our span is very similar to span, but you can capture traffic from another switch, not a switch that sniffer is connected to. Okay? So how do I do this? Putting the traffic capture in a VLAN, a special VLAN called remote VLAN. Okay? So I can configure S1 to capture traffic in a port and put a copy of this in a trunk link. Okay? In a VLAN. And via trunk link, it is transported to the other switch. And here I configure AirSpan here to where the source will be the VLAN and the destination will be the port. It's almost the same configuration. It's easy, very easy to configure too. Okay? But in this case, you can go in a remote place. Okay? In a remote place in your company or school or anything you want. Okay? But there must be a connection, a trunk connection between the switches. There are another technology called AirSpan that you can capture anywhere in the world. Okay? Also uses span technology. Okay. Let's see a little bit of GNS, okay, and see OSPF messages in GNS3, okay? So when you study OSPF, we study this ugly thing here with many communications, names, and etc. here. But you can go to the wonderful world of Wireshark to see it's happening, okay? How can I see? We have here OSPF running here, okay? Good. We have the OSPF roles here. Okay, no problem. So what we can do in GNS3, right-click, start capture. It's almost like a magic. So I will capture. Let me close this one. Okay, I will capture what's happening inside my emulator. Okay, so it's very interesting because you can isolate the traffic exactly what you want. Many things are happening now, including the OSPF communication. Okay, now I'm interested in looking to the looking for the adjacencies messages. Okay, so let's do the following thing here. Okay, here we have R1 and here we have R2. Let's turn on the debug here. Debug IP OSPF adjacencies. Okay, so let's go to the interface and let's shut down. Shut down. Okay, let's see if anything happens here. Nothing happens. Okay, let's turn on it again. No shutdown. Okay. Sometimes it happens when. Okay. Just 1 second. Let's stop everything. And start everything again because it's not connecting to Wireshark. No problem. Okay. Good. It's good because we see again it's happening. Okay. Now it's good. Okay, now it's good. So let's go and see what's happening here. Okay. Debug IP OSPF adjacencies and conf p. Go to Ethernet 00. Go to shutdown and see what's happening here. Okay. And then no shutdown. Okay, no problem. Okay. What do we have here? We have here some OSPF hello packages here. Okay. So in these hello packages, we can see what is inside. Unfortunately, it's not working live, but I can assure you that will work in a fresh start of GNS. No problem. Okay. Let's see if I can see the ping. Good. It's not capturing. Okay, no problem. Okay. But believe me, it will work. I can record a video for you, okay? Later. No problem. Okay. The fact is, you can see everything happening in Wireshark, okay? Same if you want to see, here's the proof, okay? I took a picture here. It's working here in my lab, okay? It's working, believe me. Okay. And also you could see this ICMP V6 messages too here, okay? It will be beautiful, but it's not working, no problem, okay? But that's it. Final polling question. I want to know from you, what do you think about this webinar? If you learned something or nothing, if there was something new, if you were curious to know more, if you want to learn networking using Wireshark or not. So it's the final polling question. Sometimes GNS in my computer has this problem of not capturing Wireshark. I will have to restart the computer, start all again, and it's working. So that happens. But you can capture traffic using GNS3, using EVE-NG, and also you can use the excellent emulator from Cisco Viral. If you can access Viral from DevNet, it's free. Of course, if you want to have Viral at home, you will pay $200. Okay, but you can access Viral. It's a official Cisco emulator, and you can capture traffic too from the emulator. It's very interesting. And the site of Cisco DevNet, you can log in and use Viral for free. Okay, I would show you how to use Wireshark in Viral, but it would take more time than GNS. But I prefer using Viral because in Viral there is always official and up-to-date Cisco images. So it's a very, very good emulator, and it's free to use, and it's also free for our students to use. So it's very interesting. And also, the Viral has a better framework than GNS, okay, and EVE. So let's see. This is the final question. Please be honest, okay? If you will or will not use Wireshark to learn or to teach networking. Oh, yes. Most of you, yes. Okay, thank you very much. Here is working, okay? The neighbor advertisement, okay? The ICMP version, version 6 working, okay? Router advertisement, okay? Here, it's happening, okay? Okay, that's right. Okay, thank you very much. And time's up. Thank you very much. Thank you very, very much.
Hi, hello, Dr. Moises. Thank you very much for this explanation and this very dynamic presentation. We have been learning a lot. So what I'm going to do right now is just first of all, thanking all the people, not only the attendees and the audience for being with us today. We know these are very complicated times, but also the Cisco community team, like Luis, like Tony, Jimena, Gabriela, and all the people who make this event possible, and of course, Moises as well. So what we're going to do right now is we're going to use this time to clarify some of the questions that the audience have been provided to you, Moises. The truth is that both Luis and Tony have been doing an excellent job, but we will help out to clarify some of them here. So Moises, one of the questions says how to query or search for a specific DNS server.
DNS?
Yes.
Okay. You can filter, because you can filter any field in DNS message. And inside the DNS message is the address of the DNS server. So if you filter, if you right-click this number, that is the address of the DNS server, you can right-click and select the filter, and that's it. And you will see messages from and to this specific server. And of course, there is a tool in Linux and Windows called NSLookup where you can change the DNS server and observe it in parallel with the Wireshark.
Thank you, Moises. We have another question here. Is like, are there any practice sites available that you can recommend to practice Wireshark?
Of course. You can go to my friend Chris. I can put in the presentation or in the site the references of these sites. There are some sites very nice, but in YouTube you find many things, many good things, many bad things and good things. The name of the guy is Chris, and his company is Packet Life, if I remember. But I can send you this because this is very good for newbies, and also a Facebook group called Wireshark is very good too. Okay, so that's it. I can write down and recommend later in the answers there.
Awesome. What I'm gonna do is I'm gonna place this question at the forum of this event, so the information that you just mentioned is available for everyone. Okay.
Right.
Yeah, and another thing is like, what version of Wireshark do you recommend to use?
The last, always the last, stable version. Okay. The Wireshark can update itself using the menu help or automatically, but you go to the site and use always the last, unless you are using an operating system that do not support it. For example, I use a lot Tiny Linux, a version of very small Linux in my simulations. So there I can use only the 2.6 version because it's only the compatible. Okay, but if you can, you use always the most up-to-date version.
Okay, thank you, Moises. So I have a couple of questions more. One of them is it possible to run Wireshark automatically and say pickup as part of the network disconnection log or a shutdown log?
With Windows script, you can do anything, almost anything. I didn't try to do that, but I'm sure that if you use Windows scripts or Linux scripts, you can, of course, run it. Especially because there is a CLI version of Wireshark called T-Shark. So with this command line, we can do any script you want. Okay. So of course, it is possible. I didn't try this. You can try. If you do this, please tell us how you do. But I think it's possible.
Thank you so much, Moises. And let's give it a try, right? Okay, we have another one. Are there other packet capturing tools that work similar as Wireshark?
Of course, there is a lot. Okay, there is an enterprise called SolarWinds that have a capture program most sophisticated than this, designed for corporates. For example, you have TCP dump in Linux that do the same thing too. And also in Cisco iOS, there is the debug IP packets that do the same. Okay, so there are many programs that do things similar. But why Wireshark is so famous and so used? Because they use, so people use. There are more updates, there are more features, there are more help, there are more sites, there are more YouTube videos. So that's why Wireshark is so popular. Okay, and many people use Wireshark, including companies uses Wireshark.
Good. Thank you so much, Moises. And I have two more questions, and we are going to close down this session. So one of them is, what is the difference between T-Shark and Wireshark?
Okay, T-Shark is the CLI version of Wireshark. Okay, when you install Wireshark, automatically you have the command line also installed. If you want to make a script or something, you have T-Shark as a command line version of Wireshark, okay? But you will have the output in a file or on a screen, not on this beautiful UI you have in the Wireshark Windows version, okay? GUI version.
Okay, I have two more because one just appeared. What is the opinion of, well, what is your opinion about Microsoft Message Analyzer?
Well, it's another tool, okay? I don't use pretty much this tool. I only know this tool. I haven't used this tool yet. I frankly speaking, I cannot opine about this because I don't know this tool very well to compare.
Okay, good, thank you. And the last question is, if by any chance, could you please detail um, your opinion about the Cisco emulator on DevNet, if by any chance you have experience on that?
Okay, I have in my YouTube channel, but it is in Portuguese. It's a very interesting thing because you just go to DevNet, Cisco DevNet in Google, go there, log in with anything that you have. If you are a NetAcad student, if you have a Google account, if you have any Facebook, you can log in there. So once you log in, you go to sandboxes, and then you search for a sandbox called Cisco iOS Viral or something like this. So once you find it, you click there, reserve a time to use it, and that's it. It will open the emulator for you. That's it. Simple like that. All the instruction will be there. Okay?
Thank you very much. And I would like to add up some information to what Moises just mentioned. Actually, as many of you might know, the new certification for DevNet are now available. You start with the CCNA DevNet, which is the DevNet Associate. And actually, the DevNet ones, like as Moises just mentioned, just go Google, go to DevNet. They have a community where you can actually go there and they will help you out to do any project that you are looking for. It's not only that you have access to these labs and these virtual environments, they will also help you out to develop anything that you have in mind. So take this opportunity, take a chance. There's a lot of material. There are videos, there are webinars, there are everything, and you just log in there and you will get all the information. Well, Moises, the final question is it possible to capture our own customized protocol? And if yes, how we can do that?
Okay. The question is, in what OSI layer run your protocol? Okay. If in an upper layer, you can capture anything because you are capturing the Ethernet, you are capturing the frames. Okay. So everything that comes from the frames, Wireshark will show. Of course, if it is your particular protocol, Wireshark won't analyze, won't recognize, but it will show, okay? Because it's capturing on the wire, okay? But if it is a layer 2 protocol, so you will have to have a driver too, like WinPickup or NPickup, okay? So it's more difficult. Because of this, it's difficult, for example, it's difficult to configure to capture wireless communication and Bluetooth communication and also USB communication. It's not so simple. You have to put the driver there and to see what's happening. But if it is a protocol in higher layers, that's okay. It will work automatically to do nothing.
Awesome. Well, thank you very much, Moises. And with that, we are going to close down this session. All the questions that we are not able to answer, I believe most of them they were answered. I apologize. I have some issues with my WebEx, so I cannot have a look to the Q&A. But we will cover the rest of the questions on the Ask Me Anything event of this session. That is the event that you can see just right now on the screen. So all the questions that did not have an answer or that we didn't provide you enough information, we will cover them on this forum session. That will be till April 24th. It's a Friday, so we still have briefly 2 weeks to conclude. And well, before I pass on, it's just like thank you once again, Moises. Thank you, everyone. I know many of you have to rush for meetings, but we really appreciate that you are with us today. And if you would like to have a look for further information, content, or events like this, don't forget to visit us in our social media channels. We are available on Twitter, Facebook, on LinkedIn, on YouTube, and for all of you who are customers and partners and have the app, you can find information from the community and other Cisco um, communities as well. And well, if among this audience there are people who speak different language rather than English, you can find events like this one in different like Spanish, French, Russian, Chinese, Japanese, and even Moises can give events in Portuguese. So you can find great sessions like this one in our other local community. Also, if you're looking for further IT training, particularly related to learning and to everything that's actually, sorry, related to certifications, we encourage you to have a look to the Cisco Learning Network. They have a lot of seminars, webinars, content related to all these topics. The link is going to be available in the chat so you can have further information. And finally, well, thank you so much for your time. There's going to be a survey. It's going to be on a pop-up window or just in the page where you open this event. Please help us out to fill it out. It helps us out to know how we are doing on these events, what can we do better, how can we improve, and above everything, what kind of topics would you like to see in upcoming events? And well, for all of you who fill out the survey, we have a special 35% discount on any digital material of Cisco Press. That is, you can get a new book for or the new guide actually for the CCNA, the new guide for the CCNP with a 35% discount. You just fill out the survey, use this code, CSC, and you get the discount. If you have any issues with that, please don't worry, you can contact me and I will give you a hand on that. And once again, Moises, Luis, Tony, and the rest of the community team, thank you very much, and I wish you have a wonderful week.
Same for you, Hilda. Thank you very much for you all. You are very kind. Thank you.
Thank you. And guys, please stay safe and healthy as well. We see you in the next time. Bye, everyone.
Bye-bye.